Okay, so now we're recording, and I just want to get your permission to record. Is that okay, everybody?
Yep.
Yeah.
Okay, cool. So, Gabe, would you like to? Mr. B sent me something. He sent me this.
It's pretty. We just redid Geo. We just redid some of the Geo on the intakes, but it's still that. So it's two-sided intake, both underneath. And then the lines, the construction lines, they're belts. They're gonna be belts, but the belts aren't
This
really
right here.
powering it.
Yeah. So I have a question.
Yeah.
Okay. So what are these three circles right here? Does the
They're-
note come in through here?
yeah, notes coming in through there.
Okay. And then it okay, so then it goes like this, right?
Yeah, and it
And
comes
then
up.
it comes up like that.
Yeah,
Okay. And then the note comes in this way and then
it
up
comes
through
up.
here as well.
Yeah,
Okay.
and then with
Have you tested this geometry? Like,
not the
will this
geometry, but we've tested the rollers, and it's like really nice. But
yeah?
we redid geometry today. I wasn't doing that because I was with Raylia and Drive Team,
Okay.
and I think we made it less aggressive, if that makes sense.
Yeah, right here, right?
Yeah, right there.
Yeah, this is pretty aggressive.
I can ask
Okay.
Matt for it.
That's fine.
The problem
So,
is we don't have GrabCAD anymore, so
yeah,
that's actually the other thing I was doing today. I'm trying to find something to replace
the
GrabCAD.
there there's not really much. There's there's something called SolidWorks PDM,
It's so finicky.
which
3D
so
experience.
no, so there's whatever. Okay, so you'll have to figure that out.
Yeah.
I think the team should have moved to Onshape, but that's a different story. Okay,
I
so
brought
over
that up
here,
today, and B was like, "Oh no, on shape."
yeah, but I think it's the right thing to do.
If we're
They have
teaching freshmen on shape, we should just move to it. Whatever.
yeah, there is whatever. One last thing about Onshape is that they have these like plugins kind of. I don't know if you've seen them, but they allow you to create like a robot frame, like a fully whatever. It's really cool. And like an FRC specific there's FRC specific plugins
Hmm.
that like make it so it's like very nice. Anyway, whatever. Okay, so there's powered rollers here, right? And then
Yeah,
this is powered. I'm assuming all of these are chained together.
I think it's belt.
I mean, sorry, but they're all. I mean, this right
Some of them
here.
are passive. Like I'd have to check with Matt, but
Okay.
um, see how some of them are different sizes, like very subtly. That means it's for the belt, and that's just to guide it. I you
This.
might have changed some of that.
I mean, this right here is belt. That's a belt.
And there in an updated one, there's an intermediate roller between that big belt to keep
Okay.
the rollers.
So then basically this is like the common area, right?
Right. No, we're actually gonna have it if you scroll up, we're gonna have it live where that mock game piece is, and there will be some sort of servo that just pushes it into the shooter.
Okay.
And the what
So
the game piece above is because we want to have like a hopper or a shoot,
yeah.
where we could just go to the shoot or the feeder and just toss it in, and
Yeah.
then it'll be just a secondary way.
Okay. So fine. Okay. So let's see where we're at with I can possibly use as well. Okay. So, fine. So what are we doing today? Um,
Well, I think Raylia, that's more of a you question. However, I can
yeah,
tell you because I think what we're gonna need. Diego keeps complaining about how jerky the robot is.
got it.
So some way to slow down or make the throttle less aggressive, and then
On the driving, right?
yeah, on the sticks for the driving.
Yeah, so let's actually focus on that for a little bit. I think, let's see, open Team 4 Crescendo new. Get pull. Okay. Raylia, you didn't push anything, right?
No, not yet.
Okay, well that's okay. So what I wanted to do actually is okay, so this doesn't have the changes, right?
No,
So
that's still the same.
yeah, so I wish you would have pushed it, but that's fine. So what I want to do actually is have a, okay, let's see here. Figure bindings. Okay, so a few of the things we can do on, so joystick modifications. So what are a few of the different modifications that we can make to the joystick in order to like make it not jerky or to fix the steering or to fix the handling?
Well, I was thinking we could have it like so it doesn't register a certain movement. Like if you move it like a certain distance, it won't like register it as a command.
So like the deadband thing?
Yeah.
Yeah. So okay, so that's a deadband. What else? So Gabe, does this make sense what the deadband is?
Yeah, or a dead zone, like for the stick,
Yeah.
like the initial millimeter or whatever.
Yep. So initial X percent of joystick movement is ignored. Okay. So what's the second thing? What else can we do to it?
We can change maybe the turn motor, like how maybe
Let's first focus on how what we can what things we can do to a joystick to make like just the axis to make it like handle better. There's two things I can think of.
I think I got the other, but I think really we might have talked about this at a certain point.
Which is?
Oh, do you want? I was gonna let her. Okay. You can
That's
change the
fine.
multiplier on the how aggressive the ramp up is, so it's like a throttle curve. I don't know how hard that is to implement in like Java, but when I programmed my electric skateboard, it was super easy.
So change how aggressive the joystick ramp up is. Okay.
Yeah.
And then there's also change, add, it's like, yeah, okay, fine. Change how aggressive the joystick ramp up is. Do you know how you would do that? Or like what you would actually do to the raw joystick value?
I have no idea. I don't know coding. I just know FRC. That makes sense.
well,
That's fine.
I kept seeing the word slew coming up.
Okay, so there's an idea of slew rate. Okay, then let's explore what that is. And then there's also apply, something I've seen. If we go to FRC 254 GitHub. So what 254 has done in the past, and maybe 2022 they haven't done it, but let's check. So here, if we type in math.cosine, they do when they when they do their joystick stuff. Maybe not in 2022, but I know that in like 2019, maybe. I mean, I think they do it. So here, if we go to here, how do they do their let's go to their, what is it, control board, I think. Control board, Xbox controller. Oh no, is this? So here they do something with the deadband. Maybe in the utils. Hold on. Lib control. No. Util. They have a bunch of stuff there. Let's go into where they do driving. They do, if I can't find it in like 1 minute, I'll stop. Okay, I'm gonna stop. But you can do, so there's something called slew rate, which let's look into. And then there's also, you can apply like a polynomial, like an, what's it called? Not quadratic, yeah. Cubic, okay. So let's look at what these are, okay? Just, what's that, Desmos?
Yeah.
Is that the graphing thing?
Yeah.
Graphing calculator. So you see x squared, okay? So if you plot x squared and x cubed, you'll see something interesting, which is, okay, so, and then you have x, okay? So if you, let's say that on the x-axis here is the actual raw value of the joystick that you give it, okay? So if you like push it all the way forward, it's 1. If you don't do it, it's 0, half is. So, and then y is what actually you send to the motor, or you send as a command in the code. You'll see a few things, which is, you see this right here, this is straight. This is, I mean, it's a straight line. What this means is that if you like push, if you are very aggressive, or if you, let's say,
It's linear.
it's linear, but what does that really mean in terms of when you apply it to the command to the motor or to the drivetrain? What happens is it'll just go at whatever pace you're moving the joystick. Whereas if you have something that's quadratic, you see the red, you'll see as you maybe like push forward, it won't actually, it'll kind of like be delayed in its delayed in its ramp up, right? If you go to 0.5, right? If you push the joystick half as high up, then instead of getting 0.5 as what you actually send to the motor, what you're actually doing, if you have it quadratic, it's going to be 0.25. So you see how if you apply a quadratic function in there, instead of getting to 0.5, you'll get to 0.25. And if you do a cube, it's even more gradual. Does that make sense?
Yeah.
Does that make, I think I kind of explained it a little weirdly, but does that make sense, Gabe?
Yeah. No, I nod in my head. Yeah, makes perfect sense.
Okay. So like and the important aspect is you can really apply any function you want in here as long as two properties are preserved. At zero, at 0 you get 0, and at 1 you get 1, right? And in between, this is like all free game. So what we'll do, and then you can do like x to the 4th and whatever, because they're all, so what this means here is that, and I guess you can do any, x to the power of whatever. And what this means is that if you want it to be more gradual as a ramp up, all you have to do is you can just increase that value. I've seen squared used, and I think I've seen cube used. I've never seen x to the 4th used. Okay.
I've used the controller and felt it, and I think squared is probably what you want to go with if you're using that.
Say that again.
Well, I've been on the sticks and drove the bot probably more than Rayleigh has, and I would say that the squared is probably all that the driver needs.
Yep.
So we're looking for a build up to the power, right?
Yeah, exactly. It's so that at low speeds, you're not as jerky. Yeah. But what this also means, though, is at high speeds, if you just move it a little bit, like if you go from super high to like not so high, it gets very jerky there. You see what I'm saying?
Yeah.
There, let's see, ChatGPT. Let's see here. I have a joystick that is driving a robot. The driving is too, what's it called? The driving is too
sensitive.
Please recommend joystick alteration. No, please recommend a mathematical function which will smooth out the driving. Let's see what it says. I'm just curious. Look. AN. Here, let's try this. So it's saying put something in front. So let's just take x squared. Let's do 2x squared. No, that doesn't work because it doesn't respect this. Okay. So let's do this. There's also something called slew rate, right? And let's see what this is. Slew rate limiter. Can you guys see this?
Yeah.
Okay. A common use for filters in FRC is to soften the behavior of control inputs. For example, the joystick inputs from your driver controllers. Fortunately, a simple low-pass filter is poorly suited, while a low-pass filter will soften the response. Due to sudden changes, it'll wash out fine control detail. And it'll introduce what's called phase lag. Phase lag is like it's not like is responsive. It takes time before it, like whatever you give the motor before it like registers. Better solution is to limit the rate of change of the control input directly. This is performed with a slew rate limiter. a filter that caps the maximum rate of change of the signal. That kind of makes sense. Here, let's see. Okay, nice. So a slew rate limiter can be thought of as a sort of primitive motion profile. Slew rate limiter is the first order equivalent of trapezoidal motion profile. Okay, so let's actually, okay, so here's the slew rate limiter, and this limits the rate of change of the signal to 0.5 units per second using a slew rate limiter with differential drive. Okay, so all you do is, okay, so that's easy enough. So what I wanted to do actually with you guys is the following. Let's say we don't know which is the best, which feels the best. So what we're gonna do is we're gonna create kind of like all of the options, and then we're gonna have it so that that from the driver station in real time you can change the different options. Does that sound cool?
Yeah.
So basically all of the options are there. You can just like press a button on the driver station and it'll like change the settings. Okay. Does that sound good, Gabe?
Yeah.
Okay. So how do we do that?
Slider and shuffleboard.
Yeah, so let's see. And I'm also talking this out with you guys. Okay, so how can we allow modify, no, how can we set this from shuffleboard or whatever, drivers from the driver station? Okay, so we will need a toggle, so like between different options. Okay, so in this case, it's going to be slew rate versus quadratic or cubic. Okay, so that we have to find a way in the shuffleboard or whatever it's called to select which option. Okay, and then the second thing is once we have selected an option, for example, see this deadband? This deadband needs a certain value. You know, you have to set a certain value. And Raylia, do you remember how we use smart dashboard dot get number or whatever it's called?
Yeah.
To actually get the number from the driver station.
Right.
So we have to have like parameters in here. Okay. Because for example, so let's go over the different options. Okay. So we need to toggle between different options. Let's see.
Is that where you would, like, I remember we discussed something about implementation, like you make two different like options and then you have a class that implements one of the options that you created.
Ah, so that's a really good idea. That's a really interesting idea. Yeah, potentially. So we want to create a custom class which extends and it's a joystick. You see right here, this is get left X and get left Y, or which extends a joystick's reading, okay, and applies a smoothing function, function to it. Okay. So in order to do this, we need a toggle between different options. Okay. So what are our options? As we said, we want a dead band, and a dead band is going to have a double input. So so it's going to require a parameter which controls the dead band zone. Okay, does that make sense?
Yep.
So we want like a parameter that's able to be set from the driver station, which it'll change this deadband in real time. Okay. What are the other options?
The slew rate, like the
So let's
quadratic
do
and cubic.
So let's do the slew rate. Okay. So the slew rate is going to need a parameter which controls how fast a joystick can ramp up. Okay. So, and that should also be able to be set by the drivers. So that basically when you're doing your testing, a driver can say like, oh, it's like it's not as, responsive as I want it. So they can literally just go in and change the number. Okay. And then let's do quadratic. Okay. And let's stop there. And is the quadratic going to need any parameter really?
I don't think so. It's just a function.
Yep, it doesn't really need anything. So how do we actually, okay, so does this problem statement make sense? What we want to do?
Yeah.
Gabe, does this make sense?
Yeah.
Okay. So, and we're kind of like exploring this together. So in order to do this, how do we create a toggle? Okay, that's the first step. Actually, Rayleigh, a quick question is, was there something in the code that you wrote to make the slider appear, or did you create the slider directly like from the smart dashboard?
Oh, Aaron was mostly the one who was doing that. I had to leave early, but
Okay.
There's Auton selector in the previous year's code, and I guess technically in the shuffleboard still.
Okay.
And you
So
could probably just change that drop down to, because it's a drop down, not a slider.
correct.
We just use that.
Okay. So let's look at how to do that. Chooser. What's a chooser? Set default option. Okay, sendable chooser right here. This seems to be what it is, right?
Couldn't tell you.
Yeah, it looks like right here. So often teams have more than one Auton programs, either for competitive or for testing new software. Programs often vary by adding things like time delays, different strategies, etc. The methods to choose the strategy to run usually involves switches, joystick button knobs, or hardware-based inputs. With Smart Dashboard, with the Smart Dashboard, you can simply display a widget on the screen to choose the Auton program that you'd like to run. With command-based programs, the program is encapsulated in one of several methods. So let's see how the sendable chooser method works, okay? So see sendable chooser. I'm just gonna go over here to the docs, type in sendable chooser. It should be there. Let's see. Sendable chooser. Okay. So let's see. Okay. So the sendable chooser class is a useful tool for presenting selection of options to the Smart Dashboard. That's what we want. For instance, you may wish to be able to select between multiple Auton modes. Okay, fine. Okay. But I'm hoping, okay, so there is an add option, close, get selected, emit sendable, on change, and set default option. Okay, so let's take some time to see if we can get this to work, okay? So, whoop, sorry, that's my work stuff. Let me close that. Save. Okay. WPI lib. So let's get that to work. So let's go to our first new file. Darn. Hold on. Can you guys still hear me?
Yeah.
Yep.
Okay. So let's create a new file called, oops, let's go in here. Let's call it what? Joystick modifier class or something. Okay. So this is the joystick modifier class. So let's bring all of this, which is what we want to do, want to get done, into here. So this is our what we want to get done. Okay. So let's see how to do this. So the first thing we need to do is we need to toggle between different options. Okay. So Raelia, we have a joystick, so a class, right? When we first initialize, well, it's kind of giving us a lot of the, this is called GitHub Copilot. And it's like an AI, it like generates code for you. If you give it comments, it'll like fill in what it thinks the solution should be. Isn't that kind of funny?
Yeah. So that means basically at some point you can just write what your plan is, and we'll do
Correct.
it.
So I'm debating whether or not I should keep this because it looks really nice, actually. Yeah, it looks really nice. You know? Ooh. Should we write it ourselves, or here? What I'm gonna do is I am going to keep this code, okay? And I'm gonna keep it for myself over here. And then we're going to delete it and then start over, okay? So the first thing we wanna do is whenever we have a class, Raelia, what is the first, like when you create this class, what's the first function that's called?
The constructor.
So let's create a constructor. How do you create the constructor?
You have public, and then you have the same name as your class.
I think it's, is it
Is it public?
robot container? Yeah, public robot container. Yes, you're right. So public. Okay, so so now we have our joystick modifier. And when we, so let's actually do just a print statement, and let's actually run this program to see that it works, okay? So here, what we want to do is, let's say over here, where we configure the bindings, let's joystick modifier here, just like this, okay? So when we're gonna be creating this modifier, And we should see when we run the simulation, let's check that it actually runs that print statement, okay? So this is how you would debug. I mean, how you would like build the program, okay? So here's a simulation, continue. And you should see that this joystick modifier constructor thing printout is, is printed out. Hold on. Oh, what's going on? Oh, keyboard 1 here. Now it should. Joystick button 5. Oh, darn. Okay, so what I have to do is go into here. And now just create a few more buttons, a few more axes, and then it'll stop. Yep, okay. So let's look at joystick. So see, it says joystick modifier constructor. So this code is actually now working, is running, okay?
Yeah.
So so now let's stop this, and now at least like it's being created, okay? So what is the way we can okay. So when we're modifying a joystick, let's go back to here, how we're actually going to want to use it. So you see this joystick get left X, get left Y, and get left X?
Yeah.
It seems like we're going to want the same, see, wait, hold on. See, okay, so this right here is the left joystick, and this is also the left joystick. We're probably going to want the same, like whatever filter we apply or we create, we're gonna probably want this value here and this value here to go through the same, transformation. It's gonna be weird if on the same joystick, the Y is more sensitive than the X. You see what I'm saying?
Yeah.
But this right here, we might want something completely different. You see that?
Okay.
Because this right here is for turning or spinning, whereas both of these are here to translate in around the field,
Yeah.
to like drive around the field. Does that make sense?
Yeah, it makes sense.
So really, it's not a joystick modifier that we're creating. It's more like an joystick axis modifier, right? Because it's not like going to be wrapping the entire joystick. It's going to be like you see what I'm saying? It's not like we're going to be taking in a joystick as an input. It's going to be taking in like an axis as an input. Or let's actually go over here and let's actually see how we want to use this function, okay? So we're probably going to want over here to like say something like modifier dot modify input. We might want it to look like this. So maybe we'll want to call this like translation modifier. Whereas we might want another one for turning modifier. Does that kind of make sense?
Okay. Yeah.
Like we'll want one configured for the you know, this and this, we'll want another for this.
Got it.
And at the end of the day, really what we want to do is we want something called like, you know, we want to call on the translation modifier, like a modify input or maybe an apply. And then what we pass in is the actual value from the joystick. What do you think about that? Does this kind of usage make sense a little bit?
Not exactly.
Okay. So going back to, whoa, what's going on? Here, yeah. Okay, going back to the Desmos, right?
Yeah.
And I, okay. Okay, so going back to Desmos, what we're applying, so see this joystick dot get left x?
Right. Yeah.
That's returning a double, right? Which is from, I mean, double is any like any number, but this joystick is going to be giving you a value from -1 to 1, right?
Okay. Yeah.
Right? That's what this is giving you.
Like on Phoenix Tuner? Is that what you mean?
No, so this right here, this joystick
Yes.
is this
Yeah.
is basically the Xbox controller on the first port, on the first port. You know, so if you plug it into the first port, this is the joystick.
Yes. Yeah.
Okay. So when you do joystick dot get left x, okay, what this is doing, remember, if we go to an Xbox controller images.
Oh, so you mean if it's completely to like one side or the other side, right?
Yeah, so get left x is gonna get the raw value of like how much you're displacing the left x joystick in, or well, in the x direction. And so if you go this all the way this way, it's, let's say, -1. If you go all the way this way, it's +1.
Yeah. Okay.
So that this get left x value is just giving you back that raw value.
Yes.
And then what you want to do with that is and what you want to do with that, let's say the raw value comes back as 0.5.
All right.
Now what we want to do is we want to take whatever configuration or modifiers we have, whether it's slew or whatever it is. What we want to do is we want to apply the function. So instead of taking, you know, we want to basically like get the f of x of this function to get the actual value we want to send in. Does that make sense?
To me, it does.
Okay. So Gabe, when we write joystick dot get left x, what is that giving us?
When we write joystick dot get left x,
Yeah. What is it giving us?
I don't know code enough to know, but I'm gonna assume it goes, it grabs what the input is, and then you're gonna be able to manipulate that. Like if he's pressing it halfway and it's between and it's on the 0 to 1 thing, it'll be 0.5.
Yeah. So it's taking however much your finger is making this, is moving the left. This is the left, that's the right.
Right.
X is this way, Y is this way. X is this way, Y is this way. So if you want to get
the left sticks,
so the left sticks x-axis.
Yeah.
Right. And then, but we want to apply a function on top of that, right? Which will take it from, instead of, you know, 0.5, it'll take it to whatever whatever smoothing function we want.
Right.
Rayleigh, are there any questions here? Because I'd like it.
I get the first part, like with the joystick and the values, but then what I get confused about is when you apply it with the function. So when you put that value with the function, is it like the original value, or is it gonna get the changed value also? So it's gonna just keep exponentially rising, like sharper.
Okay, so let's do a few examples, okay? So what I'm gonna do here is we're gonna do something. So let's say we have this apply function. Okay. So what comes into the function is the input as a double. And what comes out is the output. Okay.
Yeah.
So, and then let's just return output. And partially why I'm doing this is so that we get very comfortable at just writing code and testing code, okay? So let's do like double test equals translation modifier dot apply of, let's say, 0.5, okay? So half, let's do first output, okay? And then let's do here 0.75, which just happened. And then third output is 1. Okay. So let's now print out first output, second output, third output. Okay, let's run this and we'll see what happens, okay? What do you think the first output should return?
0.5.
Okay, what should the second one return?
0.75.
And then the third?
1.
Why should it be the same as this value?
Because we haven't applied any like function on top of it.
Mm-hmm. Yeah, because the apply function is just doing is just like assigning the input to the output, right?
Yeah.
What just happened? Simulate robot. Okay. Let's run it. Yep. See, first output is 0.5, second is 0.75, and then the third is 1, right?
Yeah.
What happens if is it squaring it? Yeah, if I square it. Okay. If I'm applying a square, then what should this value be?
I think it was 0.25.
Yep, 1/2 times 1/2 is 1/4.
Yeah.
Right? What is 3/4 times 3/4?
9/16.
Okay. What is 9/16?
9/16, that means divided by 3.
Node
No.
9 divided by 16 is 5625. Okay, and what should the third output be?
Still 1.
Because 1 times 1 is 1.
Yeah.
Right? Because anything from 0 to 1, if you multiply it by itself, will actually go down in value, right? Because like it goes down.
Yeah.
Okay.
I was thinking that when you when the driver station will read the value, and after it applies the function what after it squares it,
Mm-hmm.
each time that it would have it would kind of build up, so the exponent kind of instead of it squaring, it'll start kind of rising to a cube, and then to like I don't know if this is making any sense.
No, I mean, say it one more time, and I think it's good that you're trying to articulate what you're thinking.
So okay, so if
And
we
Gabe,
take
please
the third
please chime in
output,
as well.
for example, so you have 1, right? So
Yeah.
if we square it once, and it's going to be still 1.
Oh, I think what she's saying.
Okay. Yeah. So
I
if
think-
you take this number and you square it, it's
Wait,
still going to be
hold
1.
on, that's not a good example.
Okay.
Okay, let's use the first input. So we squared
Mhm.
it once, right? It's 0.25,
Mhm.
and then it's gonna keep squaring it. So it's gonna
You think it's like a runaway train? It's gonna keep going. It's gonna
yeah,
So you think it's just going to square it and then square it and square it
right,
again?
right, yeah.
What makes you think that?
It's just that how I processed it was that when you when it reads the output, maybe how much time it takes to it will keep on squaring it until you stop that function.
Okay. So let's what makes you think that it's going to keep squaring it again?
So through Smart Dashboard, you're gonna select what you want to do, right? If you want to have it squared, or if you want it cubed.
Correct.
Yeah, so you select your function, and then the computer reads the value of the joystick, and within whatever time it has, it'll keep squaring that number.
Because you'll think the input will become the output, and the output becomes the input.
Yeah, so it keeps going until you change it, change the input to a different.
I see. So there is, let's see this apply function.
Yeah.
If you go here and you do this, right? If you do something like, okay, this is not something I really want to get into right now. But you see, this function apply calls itself apply.
Yeah.
And then it goes back over here to try to apply it, and then it calls it again, and it just keeps going like that.
Yeah.
If you do something like this, then yes, it'll keep doing it and it'll crash the program.
Okay.
But because, and that's something in computer science called recursion, and it's a very powerful concept. A lot of problems are solved via recursion, but we're not doing anything recursive.
So it's just squaring it once, right?
Yes, because what's happening here is a computer. It literally is what's it called? Just taking instructions. So it starts at the top, and it goes, okay, I'm going to create this translation modifier thing. Okay, done. Okay. Now here, I'm going to take this. On this translation modifier object, right, which we created, and this is its name.
Right.
Oh, dot apply. That means that inside of this class is a function called apply. And now there is a function inside of this class called apply. So what am I gonna do? I'm gonna call this function, and I'm gonna pass these things in as inputs. And in this case, it's just one number. So what it's gonna do is it's gonna say, okay, I'm gonna run this function. What this function does is this input for that example was 0.5. This right here is it's gonna create a new variable called output, which is just a number, a double, and its value is set to the square of input. Then I just return. So and then once it gets to here, right, it's just gonna do the same thing again, but as instead of the input as 0.5, it's gonna be 0.75. So there's nowhere in here where we're calling ourselves. So it's not gonna ever like recurse on itself and break.
Okay, yeah. Okay, that makes
So
sense.
so and then you see here, this is actually what we saw, right? 0.25 and then 0.5625. So this right here is the act of doubling, of applying the quadratic, thing to it. Okay.
Alright, so it's not necessary to like stop it before you put in a new input.
No, what we're doing is,
It only picks it up once.
yeah, like y equals f of x. You know, you hear that all the time in school.
Right.
It's a very powerful, like in high school, you just think, oh, y equals f of x. But really, f of x is such a powerful term. Why is that? Because f of x means that if you're taking an input and transforming it somehow to an output. And so that's really what we're doing. You're applying a function onto x. So you're taking x, you're making it go through this like function thing, and what comes out is plotted on the y-axis. So f of x is like a very powerful kind of term instead of y. Like, what is y? Y is just, I don't know, it's just a letter. But f of x means you're taking an input, which you're calling x. In this case, we're going to be putting into it the joystick value. And what we're doing is we're applying whatever function on top of it, and we're getting out a new value. Okay?
Yeah.
Okay, does this make sense?
Yeah.
Okay, so now that this is starting to make sense, does this make sense? What this is doing?
Yeah.
Okay, it's the same exact thing, right?
Right.
Okay, so what you could do is just that. And that. Okay. And then we want a turning modifier. And we're going to wrap this in the turning modifier. Okay. Just like that. Let's see if formatting does anything. What the heck is this formatting? Okay, I don't know. Okay, this is interesting formatting. What I would like to see is something like this. But I don't know if it'll mess it up on me. Let's see if I save it again, will it? Okay, whatever. I wish the formatting is a little nicer, but okay. So that's what this is doing now, okay? And at this point, what we can do is if whoever tells us what they want the function to be, a slew or a quadratic, we can literally just go into here and just apply that function, right? Apply that in here. Okay.
Alright.
Would he type in like x squared, or it'd be drop down?
So that's a really good thing, which is, it's a really good observation. It's like, okay, so what would he actually have to type in? What we're gonna do, just because it's a very good learning opportunity, and also it's very good to test different options out without having to restart the robot and to like, you know, to take half an hour to write new code and then deploy it. Because like really the speed at which you can test something, and also the speed at which you can test something and then try something else, the easier you can like say, oh, this one is better for me. Does that make sense?
Yeah.
It's like if, oh, I want to do cubic, you know, or whatever. But then, so you like redeploy, you turn off the robot, you push the new code and start it over. He's going to be like, or whoever it's, he or she is going to be like, what was the previous one like? I don't know which one is better, because like you have to turn off the robot. But if you could like press a button and like immediately feel it like acting differently, you can be like, oh, this one is nicer. Does that make sense?
Yeah.
Okay, Gabe, that makes sense.
Yeah, especially it's Diego who's gonna be driving, FYI, but especially because turnaround times and just getting reps in is so important.
So that's why we're going to figure all of this out, and it's also going to be a very good learning opportunity. Okay. So the first thing is, how do we create a toggle for different options? Okay. So that was using something called, now you guys mastered that part. Okay. There was a slew rate limiter and then the sendable chooser. So let's figure that thing out, okay? What is a sendable builder? What is that? Sendable, this is interesting. Let's try a sendable chooser. Okay, so sendable chooser. Let's see, okay. So let's figure out how this thing works. So what I like to do whenever I see something new is I just try chooser dot, and here's all the options. So it says add option. So let's try adding an option of like option 1. And what is the second parameter? It's an object. Let's see how to use it, because I don't know what that means really. So sendable chooser, how does this work? Okay, setting up options. Chooser allows you to pick from a list of defined elements. In this case, strings we defined above. Okay, so they set different strings, and these are like the different options. Okay. Add option. So how does add option work? See K custom. So here is the name that's shown on the screen, and this K custom auto is, okay, so it's just a string. But it's, okay, so let's try this. Option 1, you chose option 1. Okay. And let's add like 2 options. I think this is how to do it. And we'll check. You chose option 2. Okay. Something like that. Resource leak chooser is never closed. Okay. Let's see. Okay, so this right here, smartboard dash. Okay, smart dashboard put data.
Really, weren't we using shuffleboard?
Yeah.
It's like the same thing.
Okay.
Yeah, smart dashboard. Yeah, it's the same
They're
thing.
interchangeable.
Kind
Yeah.
of.
It's just UI essentially.
Yeah, so basically, how the robot communicates with the dashboard with your laptop is through something called
Whatever.
network tables.
Oh, okay.
And network tables is so what is network tables? It's kind of like, and on network tables, it's kind of like, is there like a picture or something? Network tables is basically like a notebook. You can think of it as like a notebook that both the robot and the computer can read from. So if they have to exchange something between themselves, what if, let's say, the robot, right? What this is doing is, see this put data? Whenever there's a put and there's a get, you do smart dashboard dot get, you see all of these different types of data. You can get a Boolean, you can get a Boolean array. Boolean is true or false. Get number, so get a number from this like notebook, or get an array of numbers, get a list of numbers, or so on. So what get does is it's saying, like, this is running on the robot, and this right here is telling the robot to put this chooser thing onto this notebook. And then what happens is, either if you're using
Smart dashboard or shuffleboard.
smart dashboard, shuffleboard, they're all reading from the same place, which is the network table. And then they're like displaying it on, they're displaying it however they want. But in code, how to do it is smart dashboard, and that's just putting it onto the notebook, onto the network table.
Oh,
And
it's not actually putting it on smart dashboard. It's putting it on network table.
Yes, the network table is the middleman, is the middle person.
Okay.
It's the middle thing that anything can read from.
Kind of goofy that it calls it smart dashboard then.
Yeah, it is kind of. It should be called like network table or something.
Okay, cool.
Yeah. But yeah. And then this right here, when it puts this chooser thing onto this notebook, it has to give it a name. And this key is the name that it gives. Okay?
Yeah.
Cool. So that's what this is. Okay? And this is not auto choices. This is going to be called like joystick options. Okay? So when I run this, what should happen is, hold on. Nice, cool. I like it. Oh, I see what it's doing. Okay. Okay. So when I run this, I should be able to simulate robot. Oh, it's already running. Well, hold on. Okay. Sim GUI. Who's here? Admit. Hello. Now I should be able to open up Smart Dashboard, I think. Truman?
Hey, how's it going, guys?
Hey, how are you?
Not too bad. How you doing?
Doing well.
All right.
Okay. Let's see. Start tool. Can I see it in advantage scope? So does somebody want to clue Truman into what we're doing?
Yeah.
Up really you want to or
Sure, I got it. So we're using a swerve drive, right, for this year's season, and we're having kind of an issue with making it having smoother driving. So we're gonna have two options that the drivers can choose from the driver station while they're driving. So the first option is like a deadband. So we're gonna make on the joystick like a limit of where the command will trigger. And then another option will be changing like the sensitivity through a mathematical formula. So you can choose from, I think we're doing quadratic and cubic.
Right. That makes sense. Thank you.
So let's take a step back just for a quick second. I think that was a great explanation, just to give a little bit more insight. So we have swerve drive working, but somebody mentioned that it's too like jittery or something like that. And so what we want to do is we want to give the we want to basically apply some sort of in code, like make it so that it's smoother, so that the driving is smoother. And so the first thing what we did is we said, well, how can we make it smoother? And so there's a few things that we can do. The first thing is, well, there's a joystick, like apply a deadband. Have you heard of that term?
Yeah, like a dead zone with a controller.
Yep. So apply a deadband. And then also, so these are the primary two methods that we came up with. In FRC, a lot of people like the slew rate. And what that is basically if you like go from 0 to 100, like really quickly, you don't want the robot to be like, oh, okay, going super quick now, right? You want it to like ramp up. Like, so you're changing how fast the joystick or it can get to that value. So that requires a certain input, which is kind of like the parameter of how fast the joystick is allowed to go from 0 to 60. Okay.
Right.
So basically you're throttling how fast you can go at once. I'll be right back. My son is up. I'll be back in a minute. Hold on. You guys can keep talking.
Truman, are you in LA? Are you in San Francisco?
Right now I'm actually in Alaska, but I will
okay.
be in LA on Monday.
Okay. Weren't you at you went to school in San Francisco?
Yeah, I did. I just graduated last
word.
month, so I will be back permanently, I guess.
In LA or in San Fran?
In LA.
Okay. Why do I remember you doing CAD? Did you do that too, or?
Yeah, that was my main job while I was on the team before, just because we didn't have a lot of CAD, but we definitely don't have a lot of programming. So I told B that I'm probably going to take a step back from CAD this season and switch over to this department. to make sure that
Okay.
we have as much help as we can get.
Well, Kadingus is doing CAD, so
Yeah. So I'm just gonna leave him to that. I will. I'll trust that he's doing the right thing.
well, that's not the best choice, but whatever.
Yeah. It's the only thing I can do.
I'm more on CAD and I can't do programming, but I know FRC more than like Raylia and the rest of programmers because I'm a senior. So
Mhm.
I've just been. This is my first meeting sitting in with Adam, but I was working with the programmers all last week and today. And so I just figured I'd join so I could just keep relaying and bridging gaps.
Yeah, I like that a lot.
Actually, we don't have GrabCAD right now. I'm working on finding an alternative. So it's really just one computer CADing.
We don't have GrabCAD?
GrabCAD shut down.
Oh no, it did not. Did it really?
It shut down in June, and
No kidding.
I was under the impression B didn't want to spend money on a BOM or a PLM.
Mhm.
So I've been trying to find free ones, and today he's like, you can spend money, and I'm like,
I mean, yeah, you can get like a industrial
education
license or whatever, education license. Yeah, get
Yeah, we
a little
might
cheaper
do
for the.
open BLM. I doubt that rings any bells, but yeah, that's been a problem.
Yeah, no kidding. Well, I wish you luck in that. I'm glad you're trying to join here too.
Yeah, Adam, for this, oh, you're muted.
Yeah.
For the slew, I don't know why I didn't think about this earlier, but I guess swerve is kind of always on brake mode, so it doesn't like coast away because you want it to be snappy. And I was talking with Diego, our driver, today about how in game, if let's say you have to go back like 20 seconds and you want to do a sudden direction change, what he was doing on the stick was kind of going around so it's smooth. And I told him to just completely switch, right? Does that make sense? Like just pull straight back on the stick, not go around the world, so to speak. That's the term I used. You think
Say that again?
Say it again?
What's the problem?
There's no problem. I was just letting you know. I wonder how the slew will kind of deal with how snappy the swerve is.
It should make it so it's not snappy at all. It's not really so snappy. You mean like jittery? Like it goes like, full forward, full backwards?
Right. So when we were doing drills today where we'd call out location and sometimes we'd like say, let's say we say left, right, sometimes or up, down the field, up, down, middle. Sometimes we'll go like go up and then we'll go straight back. So I told him to pull straight back on the stick, right? To get to the next place as fast as possible. I think part of it, the gears and everything, we're handling that really well. So I feel like we shouldn't want to limit that too much. But I guess that's something that the slider will take care of. The fact that we have options. It's not really a problem, just letting you know.
So one thing so really quickly, so the first thing we want to do is exactly to that point, which is we have different options. We have quadratic and we have slew that we're going to handle right now. What we're going to do is we're going to make it so that in real time, like as you're driving, like as he's driving, he can like go and select, okay, I want the slew rate option, and it'll give him that as an option. So then he can like really test, let's say slew rate. Let's say I'm using slew rate. Well, now that he's doing that, he'll have a slider which he can adjust the slew rate. So then he can test in real time, like, which value is best. Because like if you look, for example, at like, I don't know, 254's code or something like that, you'll see these numbers, right? And they look like random numbers.
Yeah, I was trying to find it on 2910s, but I didn't have any luck.
What?
Slew rate or how they were doing this.
A lot of teams use slew rate. We'll probably end up using the slew rate and not the quadratic, but I'm just adding this as kind of like, why not? And it's also a good teaching opportunity. But then even with the slew rate, you're going to want to have it adjustable so that he can, he can like basically tune the robot to his preference.
Yeah.
Okay.
Yeah.
So what I did is, here, let me go to this again. Okay. Okay, so the simulator is running, and now I'm going to open up Shuffleboard. On my computer. Oh, do you see the Shuffleboard?
Yeah.
Okay. Why is it like full screen? There we go. Okay. This is not it. Okay. So here. So here's the Shuffleboard. I'm not sure what this is. Is it? How do you operate it? Okay. So you see this network tables here? Does this look familiar? Or does this sound familiar?
Yeah.
So under network tables, this is the middle, like the notebook I was talking about.
Okay.
So we have all of these different things being put onto the smart dashboard. All of these things right here are from the Swerve drive. And you see this joystick options?
Yeah.
Does that look oddly familiar?
Yes.
So maybe we can just drag it over here. Ooh, look at that. So here, he'll be able to go and say option 1, option 2. You see the two options here, option 1 and option 2?
Yeah.
So we're going places, right? So does this make sense how we're slowly building up the solution? So literally, Diego is going to be able to go into here and then test the different options. Okay. So with that being said, what are the actual options that we want?
Well, we definitely want like a formula option. So
Nope.
using
What are the
quadratic.
different? Yep. So quadratic. And then what else?
And then either slew or deadband.
Yep. So slew. And then really, in both of these solutions, you're going to want the deadband. So what we're going to do is we're going to have the deadband be able to be set on both of these options. Okay.
Okay.
So now let's so now let's see. Okay, so the next question is, how do we react to quadratic being selected versus slew being selected? Okay. Oh, the other option, of course, is linear or no let's just call it linear. But linear is basically like you're not modifying it at all. Does that make sense?
Yeah.
Okay, so we're gonna have linear, quadratic, and slew for Diego to choose from. By the way, is it Diego Gomez?
Yes.
Okay, because back in my day, Diego was him.
Also a coder at Disney.
Huh?
Also a coder.
No, he Diego was not in programming. He was
Okay.
He was a CAD guy. He's an
in CAD.
engineer.
Yeah,
What
he's
is
at,
he?
he's at Disney now.
Oh, is he?
Disney Imagineering.
Oh, that's cool. There's one of my favorite teams, like hands down. Well, one of my favorite teams. Do you know? Have you heard of 1717?
No.
They're no longer a team, but they were like literally like they dominated. And so basically they were from I think up north somewhere, and they were a senior only team, and their uniform were jumpsuits, and they would like walk around, they would like basically roll up to the competition, and like you feel like they're just gonna like dominate. It's like crazy. And then they ceased being a team because their head mentor was a little there was some politics there. He whatever. But why do I mention that? They were sponsored by the Disney Imagineers, or Imagineering, is it called?
Yeah.
I don't know.
We're sponsored by them now.
Oh, are we?
It's $2,000 from Diego.
Very nice. Okay, so WPI lib. So here we're giving the three options, okay? And now the question is, if I select linear, I want to, have linear, or I want to, I want it to like act in a linear fashion. But if I switch to quadratic, like on the fly, somehow in my code, I'm gonna need to like be able to act accordingly. So chooser dot on change here. Nice. So I think there's an on change method, and we'll test this out. Whereas when you change them, this function will run.
Isn't that syntax for supplier?
So very good. So you see here, this is actually called a consumer. And so you're exactly correct. So there's that syntax. So supplier, and here, let's look at this for a second. So Java supplier consumer. So these are like two sides of the same coin, or I don't know if that makes sense. But so let's see. Let's go to supplier. Remember, you know what a supplier is, right?
Yeah.
We've done this many times. So yeah, so this is a supplier. And what is a supplier? It's a function that, so you define it using this syntax, and when you call the
Okay. You done? Okay. My headphones lost charge. Can you hear me?
Yeah.
Okay. So and then when you call the get method on a supplier, it'll like basically call this function and return the value. Whereas a consumer is kind of the same thing, but instead of supplying a value, it consumes a value. So you'll see over here, basically this on chain. So you basically like pass in this function, or you pass in this consumer. And then whenever the chooser senses that something has changed, i.e. you changed options, it'll call this consumer. So this is kind of like consuming like something from the chooser. I don't know. Does that kind of make sense?
Yeah.
Okay. But yes, very, very good. I'm really glad that you mentioned that. Okay. So this should say you chose. So if I rerun the simulation, and we're getting closer here. I don't know if you see it, but we're getting closer here. Do you see how we're like building up the solution?
Yeah.
Okay. So now, shuffleboard. So how many options should there be?
3.
3. Let's see. 3. When I click on this, you see it runs this code. You chose option 1. You chose option, well, see, you chose option 2.
Mm.
So now we see it starting to work. Okay. So now it's getting intense here. Okay. So when we call linear, what do we want it to do? How are we going to make this apply method change how it acts? What do you think?
Are there switches in Java?
Yeah.
Can we do that?
Mm-hmm.
Okay.
So what is a switch? Let's see here. Mm-hmm. So either we can do a switch. Mm-hmm. Let's do that. You suggested it. Let's do it. So what we're going to do is we are going to have a member variable. So Raelia, what is a member variable?
It's a variable that you declare in the class, and then you're gonna have to save it.
So
in
member
constructor.
member variables are ways of it's what is it? It's saving variables for later, right? That's the English way of saying what a member variable is. It's like anything you want to save in memory. Okay, so let's save the option, like the option we want, or the option we want to use. So I'm gonna call this string option, and I'm going to default this to linear. Okay, so by default it's gonna be linear. So chooser dot default option. So set default option is linear. Okay. And what I want this consumer to do is to just change option equals option equals, I think this is already a string, is it? Unchanged. Already be a string, so I don't know how to do this. Yeah. So this is really called new option. So what is this doing here? This is setting what the new option is going to be. So whenever you change the option, what it's going to do is it's going to say you chose blah, the new option, and then it's going to update this member variable. And then I'm not sure who mentioned it, but who mentioned the switch statement?
That was
Truman.
me.
Gabe?
No, him.
Okay, Truman?
Me. Yeah.
So what is your thought here?
I mean, a switch will usually have as many arguments as you want, and then a default. I mean, I guess I don't know. I don't know if I want to use linear as a default, but anyway, if you just have a switch between all three of the options here, you can call the apply function with different inputs, whatever you wanted for each of them.
So there is, before we go to switch, let's just do if statements, okay? I mean, yeah, like switch can. So what we can do is this, look, if, yes. Something like this. If the option is equals linear, then what we want to do is what should we be returning? Just the input, right? Because this is what it means to be linear, right? Whatever comes in, you just pass out. Y equals X. That makes sense?
Yeah.
If the option is quadratic, we want to do this. Okay? Does that make sense?
Yeah.
Okay. So now, the last thing is, how do we get slew to work? Okay. I guess there's two questions.
I guess we just have to think about them.
I have no idea how slew works.
I don't either, because I don't even know what he's talking about with that. Did he talk about that at all before?
I think it's just a way of, instead of quadratic, it's
Hello?
just like a throttle curve. Oh, hi.
Sorry,
It must be the is slew the one you were talking about with like an incremental increase in
yeah, it limits the rate of change.
okay, right.
I'm a little older. Do people still use the word yeet? Like
Sometimes, I guess. Pretty
okay,
rare
because
now.
I was just talking about this with my wife, and I was like, my wife doesn't know any of the new slang or whatever, and I know some of it. And I was telling her about the word yeet, and I was like, that sounds so stupid. So whatever. So it was in my head, and I was like, I accidentally quit the browser, so that's why I left. And the first thing that came to mind was I just yeeted out. Right.
Yeah,
But
you're
yes.
a couple of years late, but I
Okay,
think
that's
everyone
fine.
understands.
I don't know any of the terminology nowadays. So I never thought I'd be that person, but okay.
Happens to us all eventually.
So slew rate limiter. Let's just go over this one more time. Okay. It's common use in FRC to soften the behavior of control inputs. For example, the joystick inputs from your driver controls. Does that make, I mean, this seems very similar to what we're trying to do now, right? So,
Yeah.
Fortunately, simple low pass filters. Okay, that's fine. So let's see how we can actually implement this. Creates a slew rate limiter that limits the rate of change of the signal to 0.5 units per second. What does this mean? If we put in 0.5, And let's say within a millisecond, we go from 0 to all the way forward. What this will do is it'll take 2 seconds, I think. It'll take 2 seconds in order for that, the system to register 100, to register full forward. Does that make sense?
Yeah.
Like,
is this universal? Like, sorry to cut you off. If we instead accelerated to 50%, is it still going to take twice as long to get to 50%, or is it now going to take just 1 second because it's half a minute?
I think I think what it'll do is it will 0.5 units per second. So if you go from 0 to 0.5, it'll do that right away. Because the rate of change, if you go from 0 to 0.5 is 0.5. And what this is doing here is it's limiting the rate of change to 0.5 units per second. So it's not like hitting the limit. The reason why over here it says the slew rate limiter is the first order equivalent of the trapezoidal motion profile. What that's saying, trapezoidal, let's see if there's a, oh, come on, they don't have a, oh, they don't have, okay, they don't have like pictures or like explanations. Fine. Okay. Here, trapezoidal motion profile. Actually, very, very cool. Okay. So, do you see this right here? There's a very cool picture. If I can find it. I'll only spend like, so basically the idea of trapezoidal motion profiling, which when are we doing a climber?
Eventually, but it's not set up yet.
So when we get to a climber, if it's like an elevator, I don't know if it will be, then we'll be using a trapezoidal motion profile. But basically the idea is that see here on the x-axis is time and on the y-axis is velocity. So what you want to do is, I mean, really what you want to do is you want to go at, a certain velocity and then go back down, to rest, right? So do you see my cursor?
Yeah.
So like if the fastest way to get to maximum velocity while still getting back to 0 at this time is to go all the way up till halfway and then to go back down. Does that make sense? Like go up, 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 and then until you get to halfway, then so spend halfway getting to as fast as you can, then spend the other half going back down to 0 velocity. But the idea is that that will be like there's like it'll be like too jerky. So a trapezoidal motion profile is kind of like it caps the velocity off at a certain like velocity. So what happens is you take that ideal of going super fast and then going back down, you kind of like take that and you intersect it with a horizontal line, and what you get is a trapezoid. You get up, smooth velocity for a while, and then going back down. Whereas with a slew rate limiter, that's kind of the idea, is that if you hit the limit, then it'll limit you. But if you're operating under that limit, so in the case that you just mentioned, it won't actually limit you. So this is how it kind of like allows you to do like to act perfectly in low speed, in low speeds. But when you get to super high, you like limit the jolting. And that's really what we're trying to get at. Does that make sense?
Yeah.
Okay. So here's linear, here's quadratic, and now we need to do slew. So how does the slew rate limiter work again? So what happens is creates a slew rate limiter that limits rate of change. Okay. So what happens here is we can literally just copy this code. Slew rate limiter. Okay. And I mean, really, you can just call calculate. Yeah, calculate. Oh. Yeah. Okay. So that's it. So this should never be reached. Okay. So this is how we'll make the apply method respond to this sendable chooser. Does that make sense?
Yeah.
Okay. So the first question is, was this hard?
The process that we did right now, no.
Right? But it was like, if I were to tell you to create a drop down so that on the fly somebody can change to test out different driving or joystick styles, you'd be like, I mean, if I just tell you that, would that be easy or hard to do?
Well, if this process wasn't explained at first, then I'd be stuck.
Cool. That's exactly what I'm trying to get at. It's like we're trying to develop our programming and really all of engineering, like, machining, CAD, all of this stuff that we're doing in robotics is training us how to be problem solvers. Okay. And so what a problem solver is like you take an idea or you take something you want to do and you have to like figure out how to break it down into like manageable chunks and like build up the solution. So I'm glad that you're learning this, because now when I tell you, okay, I want to have like 3 or 4 different auton modes, can you create a drop down to select different auton modes? You know how to do it. The sendable chooser thing, right?
Yeah.
So we're not done here, because you see this here still is hard-coded.
Right.
So we need to do 2 more, and we have 2 more things. One thing is this is hard-coded, and we want to make it to get that value from a smart dashboard,
Mm-hmm.
like as an input. And then number 2 is we have to implement this deadband, okay?
Yeah.
And also have the deadband come in from as an input. Okay, so does that make sense?
Yeah.
So the first thing is, let's say we want to change this value from 0.5 to another value. This right here, when we created it, it had a hard-coded value. But if you only create it once, but like, how are we going to change that value on the fly? See what I'm saying?
We can make a slider on a smart dashboard like we did.
Yeah. So let's say you make a
Early.
slider. The slider works. But how do we actually update this slew rate limiter with the new value? Because it's like you this right here, you're creating the object for the first time, right? But you don't like create it every single second, every single time you call the apply. We could, but can we? That's kind of like wasteful. So the question is, can we augment this value on the fly? Let's see. If I go to slew rate limiter dot, let's see, calculate, which is what we use, equals get class. No. So what this is showing me here, oh, reset. What does reset do? Ooh, interesting. Let's see. Okay. Never mind. So reset isn't what we need. Okay, so what we need to do is when we select a new value, we actually want to reset, or we want to sorry. When we update this value, we have to actually recreate the slew rate limiter with the new value. Okay, so let me ask you a question. Oh, interesting. How do I do that?
Can we put a listener on the slider?
Yeah, I was just wondering, because like this right here is a listener, right? Sorry, this on change is is a listener, but that's on a chooser. We're not on a chooser. So let's see if there's a way to represent the slider in code, because if there is, then we can listen to it, right? See this chooser here? This is called a sendable chooser. Wait a second. Didn't Aaron do something about this? With this?
I know he did like a put number with the smart dashboard to make a slider.
That part let's see. Widget. Okay. So configuring widget. So this is kind of what we need. So shuffleboard dot okay. So configuring widgets. Let's see here. Configuring widgets. Nice. Okay. Let's try this. Let's put it here. Now the shuffleboard is in scope. Nice. Okay. See this get entry thing? So generic entry, generic entry test is equal to that. Okay. So let's see here. Test. Okay. Test dot Notify? What does notify do? That doesn't look right. Get entry. I mean, okay, yeah. So we'll have to do it ourselves. Okay. So the first, well, hold on. Add max speed, get entry. Okay, so here's how you do min and max. Okay, so what this is showing me is a few things. The first thing is we can so what we can do is let's create okay, shuffleboard drive, let's see. Or let's say like joystick, I don't know. And then this, what is the name of it going to be? What's its name? Its name is going to be slew rate. Okay, and let's default that to 1. I don't know. Let's just see what it is. Okay, so let's simulate robot code. What just happened? Okay, let's try it again. Oh, is it not like this? Idle is already in use, slew rate. Why? Okay. Slew rate value. I don't know. Let's try. Simulate the code. No, they did not like that. Why? Oh. Is it because, oh. I know why that's happening, but we'll fix that later. So let's just make sure this works. Here. Yeah, okay. So now I'm going to open up the shuffleboard. Okay. Oh, joystick has a lot of. Wait, joystick. Where's the slew rate? What is all of this? Can I just delete it? Remove. Remove. So now let me go into here. Joystick slew rate value. Nice. But that's not a. Oh, I see. I just messed it up. So start tool, yeah, shuffleboard. Okay, so I guess what this is doing here is it's not like, okay. Joystick, is one of these like a slider?
You need to click the joystick tab. Is that what that is at the top?
Oh yeah, I thought I was
Okay.
in the okay, yeah, so here is the slider. Okay, so now we have a slider, right? And now what we need to do is make the code react to that. So how do we do that? We have to, there's not going to be a built-in way to do that. So we're going to have to do something interesting, which is what? We have to hold on to the previous. Okay, this is fun. So what we're going to have to do is we're going to have to like hold on. So let's say here, double current slew rate, pull previous slew rate. Okay. Uh-oh. Okay. So what we're doing here is we're going to have to need to manually check for changes in the slew rate. Okay. But basically, there's no way of like, or I don't think there's a way of having like a callback. In JavaScript, it's called a callback or like a notifier of when this value is changing. So what I'm going to have to do, because we're going to be calling apply every single loop cycle, right? Because we need to get the newest value, the newest joystick value, right? When we're driving. What I'm going to have to do is up here or in the apply, I'm going to have to, yeah, look, check if the slew rate has changed. So how do I do that? Ooh, this is cool. Does that work? Joystick. Let's see. Oh, did I shut down the, yeah, where's the shuffleboard? Let's go start tool, shuffleboard. Okay, so see this slew rate value is 0.47 right now. What I want to do is I want to figure out where, see this 0.47? I want to get that value in the code. So you see how it's shuffleboard slash joystick slash, I'm sorry, shuffleboard, and inside of that is joystick. Inside of that is slew rate value. Do you see that?
Yeah.
I think the way of pulling that from, that's all in the network tables. Okay. I think the way to pull it from the network table is with slashes. So let me check something, okay? Actually, this is an entry right here. Okay, so I can just do this, like generic entry, slew rate entry, and I can do this. slew rate entry is equal to that. Okay. So when I created this this slider or this value and I pushed it to the shuffleboard, I'm actually saving in the memory the actual entry. So what I should be able to do is if this one. So if you do slew rate entry dot get double,
I have a question.
yes, of course.
What's that syntax with the exclamation mark and equal sign? It looks familiar, but I just don't remember what it is.
Yeah, it means if it doesn't equal. So
Oh,
I think
okay.
in Java,
Yeah.
equal means if the left is equal to the right, then do something. I think, and then the exclamation mark equal means if it's not equal. But what I'm curious about, I see. Okay, I was like, why am I passing in a value if it's not equal? Sorry, if it's getting a double, why am I passing something in, right? And so I think that's what I want. Let's see. If my slew rate, okay. So if my slew rate entry is not equal to the current slew rate entry, and if it's not there, then this is the default value. If it's not the same, then what I need to do is what is this? Oh yeah, okay, so yeah, so can somebody explain what this is doing here?
Can I try?
Yeah, of course.
So I'm saying that if the slew rate entry is not equal to the current slew rate, then it'll like make the current slew rate equal to the entry, and it will also set the limiter as a variable.
Yeah, so what it's doing is exactly if the slew rate has if the value over here changes, okay, then the new slew rate is not going to be equal to the current, which is like saved in memory, right? It's going to be different. Right now it's 1, but when I ran this, it's 0.47. Okay, so what it does is it gets the value, the new value of 0.47, it puts it into memory here, and then it creates it overrides this slew rate and it recreates the object, right? Because see this up here. Wait, hold on. This you have to pass in you have to give it a value. So basically, like if the value changes, this object is like trash. You have to recreate it with the new slew rate. Does that make sense?
Yeah.
No. Okay. Okay, so let's see here. Okay. And I'm not using the previous. Hold on. I don't need previous, actually. Why do I need previous? Oh,
I don't think you do. I think if you just replace that with current slew rate, it'll work
Yeah.
the same. because it'll read it before it reassigns it.
Yep. I think this looks good. And now something that's interesting is slew rate limiter dot reset. I think I'm going to do a reset. Why is that? Because this resets the slew rate limiter to the specified value and it ignores the rate limit. Basically, remember what slew rate is doing is it basically takes the last value and then the newest value. Then if the difference here, maybe we can look at how the calculate works. See this calculate here? This is actually what the slew rate is doing. We can just literally read the code. Here's the elapsed time. Okay, we take the current time, we subtract it from the last time calculate was called. And then it does this, look. What it does is it tries to take the input and, okay, hold on. It like this clamp, what it does is it like calculates this value, but if it falls outside of this range here, then it'll like clamp it to, if it's too low, then it'll set it to this. If it's too high, it'll set it to this. It's like it really is kind of like a deadband.
Okay.
This is actually how we're gonna implement the deadband with the clamp function. Okay, what does the clamp function do? Takes in a value and a low and a high. If this value is lower than this low, then it'll return this low value. If it's higher than this high, it'll return the high. But if it's within the low and the high, it'll just return this value. That's what this clamp does. This is very important. This is a very important function. So this is how the slew rate limiter works. So what we're going to have to do is if I don't do this reset thing and I just recreate this, it's going to assume that the last value that the slew rate was set to is 0. But that's not the last value because we're like doing this on the fly. Does that make sense?
Yeah, also, I want to let you know that I'm going to have to leave in like 5 minutes.
That's okay. So does that make sense?
Yeah.
So what we need to do is we have to remember what the last input is. Remember, this is the new input. So what I have to do is double last input. Oh wait, that's gonna be, oh no. Okay, I guess that's how it has to be. Okay. The issue is, okay, fine. So what we're gonna do here So what this does now is even though we're recreating the slew rate limiter on the fly, it'll work as expected, because even though we created it brand new just right away, we said like slew rate limiter, pretend the last input you saw was, I don't know, 0.25 or whatever. So that'll work. And then here's, so okay. Okay, I think this should work. This seems to make sense to me. Okay. This doesn't seem to have any issues that I see. Okay, one more thing is we want a deadband. So let's do double deadband Let's set it to 0 for now. Okay. And let's just see if there's the FRC utility for deadband. FRC WPI lib, or if we should just use the clamp. Okay. Deadband. That's not good. I mean, I know there's a deadband. I mean, I know we can just, it's not hard at all. Apply deadband. Is there a function called, let's see, deadband? Oh, that's deadband. No. Okay, so let's do the deadband ourselves. Okay. So, so let's, right now we're saying the deadband is 0, okay? But then we're gonna have to in the apply method, we can just get the set the deadband value. Okay. I think, yeah. Okay. So now we actually don't need to save it. So input, okay. So here, what I want to do is math util. Oh, look, apply deadband. They give you one right here. So how does this apply deadband work? It returns 0 if the given value is within the specified range around 0. The remaining range between the deadband and 1 is scaled from 0 to 1. Does that make sense?
Yeah.
So let's actually see how the deadband works. Let's see. Okay, so what this is saying here is, wait, hold on. Oh, that's if the max magnitude of the deadband is a large value. Here, let's see here. Okay. That's fine because they're doing like scaling. Oh, here, look, this is cool. They actually give you the math that they're using. Okay, fine. So let's just apply. Let's just use this deadband. Okay. So the first value is the value, so input. The second value is the deadband, right?
Yeah.
And the deadband is smart dashboard dot get deadband. Okay.
I'm gonna have to go now.
Okay.
Thank you for so much for explaining this.
Yeah, of course.
Bye.
Okay. Can you guys still stay on?
Yeah, I don't know how much use teaching me is, but yeah.
It's really good.
I'm here to stay as long as you are. Sorry to cut you off.
Okay, sure. So do you see what I just did here? What I did was at the very beginning when we're calling the apply, I'm actually just resetting the input to like, I'm applying the deadband, right? And I don't have to, the reason why for the slew, I had to like do this checking is because whenever it changes, you have to recreate this class every time, which is like kind of annoying. But that's what you have to do. Wait a second. Is it the last? Yeah, okay. But because so really this is how it is. So with all this said, I think this should work well. So and look. Okay, so from the outside, when you use it, the great thing about having classes is you put in a bunch of like complicated logic, but then over here, look, you just kind of use it, right? Like the code still looks simple, and you just kind of use it, and it gives you all of this functionality out of the box. Does that make sense?
Mhm.
So, yeah. And so how do we test that? I can't really test if this works well because, first of all, I don't have the robot. Well, I can test that the linear, let's test that the linear and quadratic works. Slew is going to be hard because this is like, it's not just like input output, it's like over time what's happening. Oh no, I can test it actually. So let's here, let's take this. Let's revert it. Okay. Let's actually do some tests. Okay. So here I have my oh wait, hold on. That's not going to work well. Do I have, okay, so this is the robot container. Does this have like, can I hook into the, oh no, this is just, okay. I can go into the robot, do it. Okay. Let's see. Yeah, I mean, it's going to be a little hard to test the slew, but let's test the others. So, oh. You know what I'm going to do? Here, I'm going to do this. Class, public class test command. Wait, what am I doing? Should I do that? No. Okay. I'll just do, oh. The reason why I'm kind of like a little, not confused, but whatever, is because the joystick modifier by default is going to be linear. And if I just do this, it's not going to like, it's going to run before I can like go into the smart dashboard and like change it.
Mm-hmm.
So
is there no way to mess around with it live?
Well, I can. So what I can do is here, you just inspired me. So class, test command. Yes. Okay. So have you guys heard of command-based programming?
Is this an FRC thing?
Yes.
I was reading about it a little bit, but I don't understand.
So most of my videos on YouTube, I've recorded most of these. Most of them are on command-based programming, but let me give you like a 2-minute overview. I'll refer you to one of the videos. But basically here I'm creating a command, and inside of this execute, this is actually going to run periodically. So this is where I can put some of my code in. So what I'm going to do is over here, and I'm going to do a joystick modifier. Now, initialize, I'm not going to need anything, but in execute, what I'm going to do is okay, so input of, yes, that's what I want. Input of 0, 0, 0.5, input of 1, input of, so every loop cycle, it's going to spam this out. That's fine. Every loop cycle, it's going to run this. So the robot runs periodically every 20 milliseconds. So that every 20 milliseconds, this should run. So what I'm going to do is for a minute, I'm going to make test command. The default command, this test command thing. But so now it's not going to drive anymore, but the drivetrain by default is going to be running this test command. This is just to test it out. Okay. So this should work. So if I go to simulate robot code, it's kind of a fun little exercise, and it'll actually be useful. Okay. Whoa, what just happened? Default commands must require their subsystem. Drivetrain. Test command. Add environments. Simulate robot code. Okay. Okay. Huh? Do I have to go and tell you? Nice. Okay. So you see this here?
Mm-hmm.
So every 20 milliseconds, it's going to be spamming. So if I go to shuffleboard.
What's the difference between shuffleboard and smart dashboard?
They're different like GUIs. So hold on.
Okay.
Let me go to, where is it? Smart dashboard joystick options here. I change it to quadratic. You see right here, it worked. Look,
Nice.
I go to linear, it goes to 0.5. If I do quadratic, it goes to that. Question is, so if I go over here, disable, it should stop. Good. And now what do I want to do? I want to try to like see something about the slew, but I can't like test that because that's like over time, and I don't want to. I mean, I could do like some sort of for loop or something.
Yeah.
But I don't really want to do that. So slew rate limiter dot. Can I get the slew value? Do they like expose that? It seems like they do. So rate limit, a positive rate limit, negative rate limit. Okay. And that's a private variable, so I can't. Okay. So, I mean, okay, so let's see here. So we're almost done, but two things. Oh, hold on. I also can test I mean, like that the dead band works. So, but see, this is like a dead band here. Okay, so what I'm thinking about right now is a few things. The first thing is that if you create multiple joystick modifiers, it's going to try to, this chooser, it's going to try to put all of them under, like every single time you create a joystick modifier, it's going to put data and it's going to override. So we need to distinguish them, like one joystick modifier versus another. Does that make sense?
Mm-hmm.
So how do you think we can do that?
Good question.
Okay.
I mean, you can take an input instead of just writing joystick options. Joystick options as a key. You can just take a string, I guess.
Yeah.
Some other way. Yeah.
So we're gonna pass in a name. Very good. You know what you're doing. So string name. I'm not gonna pass that. Okay. So then here, what we're gonna do is we're gonna say name. You do that. Internal name, let's call it. Okay. So internal name is equal to name. And then here, we can do something like internal name. That's, if you do slash, something happens. That's interesting. No, maybe it's too interesting. Oh, I didn't pass in a name where I'm using it.
You've got thumbs up on the field.
Nice. Simulate. Okie dokie. So now, if we go to Start Tool, Shuffleboard. What did we call it?
I have no idea.
Yeah.
Nice.
I think we called it translation. See translation? So see this nesting here? If you put a slash, it'll like show up as nesting.
Okay, cool.
So what we want to do is we want to put everything related to this translation under here. That's our goal. Okay. So something that's kind of so the next, does that make sense?
I don't quite know what you're asking.
Sure. So over here in the joystick modifier, right?
Mm-hmm.
This option is under the joystick or the translation kind of like namespace, like name. But with this joystick modifier, there's actually a few inputs from Smart Dashboard. This is one input.
Mm-hmm.
The other input is this deadband here. We should kind of like locate them together.
Right.
But what's interesting now is see this smart dashboard.get number. This is, if you look at where this deadband is, oh, this is a get. So I can just get it from anywhere, I think. So maybe what I can do is I have to like figure out how to.
Where is that deadband number being initialized?
Yeah,
code.
So it's not actually. It's not in here, I don't think. Because look, what this is doing is it's getting the value, but it's not like saying, okay, I want to create something on Smart Dashboard or.
Sure. So how does it know? It knows by key. So in some way, there's something called deadband within Smart Dashboard.
I can show that to you. So
okay.
Double current deadband. Okay. Okay. So system.out. So here's the current deadband. So let me reset. And here you'll see if I go into Teliop, current deadband, okay? If I go to start tool, shuffleboard. I just know in Smart Dashboard, but if we're using shuffleboard, then we're using shuffleboard. So it should be just I'm assuming if I right, let's see here. Work tables. Okay, so there's this pose. Ooh, that's cool. Shuffleboard, Smart Dashboard. How do I Smart Dashboard? No. Live window. No. Somehow I have to, maybe a widget. Like there's like an input or something.
For deadband?
Yeah, I want to somehow. Here, let's see. Edit properties. Somehow I need to title. No. Number slider. How do I?
Can you not just change the title to deadband and it might find it? Is that how it does it? Seems a little silly, but
I think it would work like that. Here, let's go to sources, smart dashboard. No, I think I know how to do it in, that's really strange though. I think I would know how to do it in smart dashboard. Let's check. Start tool, smart dashboard. Oh, maybe not. 4. Can I connect? Huh. Maybe.
Did you need to give it a host or a port?
I mean, the thing is that I'm not sure if it, like I'm running in simulation. So I don't know if it knows how to connect to simulation.
Oh, okay.
Let's see.
Interesting.
Let's try advantage scope. Do they have a way of table? I'll connect to simulator. Smart dashboard. No, I don't know. How would I do it? Is it really not there anymore?
Wasn't Aaron talking about this in the Slack?
Here.
Yeah.
I mean, this is how to. Maybe. So maybe our what we should do is this. Let's kill this.
He
Maybe we
said,
should- yeah.
with put number, I can grab the values from the side in shuffleboard and drag and drop them into a number slider widget.
Well, yeah, I mean, but put number. So what put number does is it allows the it allows the robot to take an internal value and put it onto the network table. But maybe what I want to do is this, like maybe generic entry, deadband entry. And what I can do here is the same thing where I just go I don't want it number bar. I mean, if I do this, this should work.
There's a number bar.
I'm not sure. I guess we'll find out. So if we simulate robot code, okay, okay. 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 Insert tool. Shuffleboard. This should work. Okay, so that works. But this is not a. This is like display.
Like a live view or something, yeah.
Edit property.
It's pretty cool though. I like that.
Okay. So, mhm. But now I know where to find it. Shuffleboard, joystick, deadband value, and if I go over here, here, yeah. Okay. You ready?
Mm-hmm.
Change this to 3. Oh, wait, it's not pulling from the right value. Hold on. So now, if I do this, band entry dot get double, and then the default value is 0 here. Okay. So now, simulate, enter. Start tool, shuffleboard. Tell ya, see, current deadband is 3.
Great.
I'll change this to 2. See, now it's 2.
Oh, I see. So I have a couple questions. The reason that the deadband value showed up in your menu on the left there, I'm not sure what that is. Network tables.
This is network tables.
Yeah, so it showed up there only because you made a new member variable, like it just automatically knows to throw it up there.
Well, I mean, this is like this widget thing is kind of like is it's putting it's like doing it's like,
oh, I see.
And it's pulling.
Right, it's titled deadband value. I thought you made a double name deadband value at one point. That makes sense. The other thing is within the apply function, you could access deadband entry. Yeah, on line 73, you could access deadband. Why is that allowed? It seems like it's in a different scope because you create a deadband entry up there in, I don't know if that's in the, oh, that's in, never mind. Yep. I thought that was in a different function.
Mm-hmm.
Never mind.
I mean,
I'm with you.
You're correct. If I create a variable inside of this joystick inside of this constructor, which is just another function, there's a special function that's called when you initialize an object, when you instantiate an object. But the reason why I'm able to access it outside of the scope of this is because, look, deadband entry is a member variable up here.
I see. Okay.
So once the joystick modifier sets it onto this, onto here, anything has access to it. That's why I'm allowed to do this.
I'm totally with you. It's a little hard to look at code when you're not the one controlling it. I keep forgetting.
To be honest, if it were the opposite, it's not easy. Okay, but so this is working, right? Oh,
excellent.
So I guess let's do. I mean, the input is like hard to simulate, but this works, right? So all that's untested is the slew rate. Cool. So now, yeah.
Sorry. I'm just trying to learn as much as I can. If you wanted to push this to the robot, how would you do that?
Put the USB cable in. And then You go
So-
for it, Adam.
No, you go.
I just remember plugging the USB cable in, and then I thought it was in the coding, which you're on now. There was a button, but I could
You
be
just
wrong.
build and then it automatically pushes, or
Yeah, so two things. The first thing is your computer has to be connected to the robot somehow, right? There's two ways of doing that. One is wired and one is over the radio.
Oh shit.
So up until a few days ago, they were only doing the wired, but in order driver practice, they were doing it wireless, right? Like there wasn't a cable connected, right? Is that correct?
Yeah. Sorry, I nodded my head.
Yeah. So that's because I had them hook up the radio, and they had an issue with like flashing the firmware to the radio, but they got it working. And so all you have to do is, if you want to do radio, it just broadcasts a Wi-Fi network, and so you connect to the Wi-Fi network, and then you deploy. Also, if you have it plugged in physically, you can deploy. And the way to deploy is you go up here. So it's a special there's a special version of VS Code. This is VS Code. I'm sure you are aware.
Mhm.
And there's a special version that that they tell you to install. So, and it comes with this plugin here, and they configure a lot of stuff in the background. So if you just click up here, it just brings up the normal. Are you familiar with VS Code?
yeah, I am.
Okay. So if you just bring up the command palette, right? Like here's a bunch of different commands that can be run. All of them are prefixed with WPI lib. And that's how you saw me getting to this.
Okay.
Or you can just click this button and it takes you to
Right.
here. So building robot code is just compiling it locally. And so one nice thing about that is as you're developing and you think something is working, first of all, you can simulate the code, which builds it anyway, but you can build it to see if there's any like compiler issues. To deploy it, it's just where is it? API
Deploy
lib.
robot code. I
Where?
saw it down there.
Okay, here you go. So you just click this button, and it'll build it. Then once it's done building from your computer, it will here, see this build folder.
Mhm.
That's what's compiled,
Sweet.
and that's what's deployed to the robot. So okay, we're very close to being done with this feature. What we should do is, see, this is the tab, the joystick tab. Do I still have it open? You know how I had to click joystick up here? So that's where I set what the tab should be. And then this is the value. What I want to do is I want to probably prepend it with name so that I can have multiple. So, but now the issue is like these are on the shuffleboard, but this is not. It's like just using regular smart dashboard. So I'm wondering, shuffleboard dot tab joystick put dot add what is this dot add? Sendable. So I think I can just dot add internal name. See, and chooser. Yes, nice. Okay. So you see this? Now I can do, what is this? Tab, shuffle, tab. Tab, close. Joystick. Now, just do tab dot add. Nice. Slew rate entry. Yes. Deadband entry. Same thing. Oh, I don't want it to be a number bar, do I?
I needed it to be a slider, I think, right?
It wasn't a slider. I just had it as a regular. No, don't want. That's a little nicer. And it's not. Wonder if there's. Have you ever used Java before?
I've used Java a little bit. I took a class a while ago. I haven't used it maybe a year, but I'm mainly a Python programmer. So yeah, I'm decently familiar with the syntax, but on
Yeah.
top of all the FRC stuff, it's
Mhm.
making it a tiny bit more confusing.
I understand. Okay, so look, it looks like this this works well. And now everything is namespaced properly. Right? These right here are, so this puts the chooser on. This configures the slew rate, and this configures deadband. And I think this is looking really nice. So maybe deadband, we should like default it to 0.05, maybe. I don't know. Figure out what the like what it should probably be. And then
Definitely
here's,
over 0, yeah.
I think it was like 0.005 or something.
Okay.
You can definitely easily check. And so now I guess let's just finish the implementation. So now we don't actually need this test command, right? This was just used to test everything. So let's delete that. Okay, so now this, let's revert all of that. And now something that we have to give up is joystick modifier Y translation modifier. Something we unfortunately have to give up is using the same modifier for both left X and left Y and left X, because we have to store the last input. And that's like only for one axis. So it's not like like completely stateless. So we have to do Y translation modifier. Joystick modifier X, and then
I mean, could you not just store a value for each of them within the same joystick modifier?
say that again.
Could you not just store a value for each X and Y within the same joystick modifier? Like a last value for each of them?
I mean, I could, but this only is going to be used in one place.
Okay.
So it's going to be like, if I wanted to, I could make the thing that I pass in, like be another class, and that holds its own like previous value.
Right.
But I don't want to.
Yeah, make it simple. I get it.
But I could do that.
Mhm.
Okay. Apply. And look, now it's like super.
So,
And they just have to be set in separately, but that's fine.
drive. Joystick modifier accepts inputs and transforms them in some way given the options we gave it. And then you're passing that result into drive dot. So drive is some interface to the motors in some way.
Give me just 1 second.
Yeah, sorry.
Say that again.
What is drive?
Yeah. So, hold on. I'll spend like 10 more minutes and then we'll call it.
Oh yeah, you can hop
So-
up whenever. I know it's late for you.
Yeah. So, command-based. Command-based widgets. What is command-based programming? So, the standard way of, at the end of the day, right? You have talons, which are the motor controllers, and you just do talon.set and you give it a value from -1 to 1. It'll make the talon go at that speed, right?
Mm-hmm.
I mean, other than that, you have to you want to create a robot, like an architecture and code that makes sense, right? But you're not like forced into anything. The only thing you're forced into is the APIs that WPLib gives you. And what it does is, like, for motors, you do a set from -1, which is full backwards, to +1, which is full forward, and 0 is stop. And so the thing is, like, what's the best way to architect your code? And what has become the standard is something called command-based programming, where you do as follows. Let's do like diff drive. This is easier. Okay. What you have is you have 3 different things. You have two basic things. You have a subsystem and you have a command. The subsystem is responsible for like for example, on a robot, this year's robot, there's going to be like, let's go back
Bunch of
to
rollers.
it's a bunch of rollers, right? But depending on how we want to program it, let's see, how many subsystems are on this robot? There's going to be the drivetrain, that's one. The shooter, that's two. The conveyor, this can all be considered one more subsystem, right? However you want to do it. And the idea is that the drivetrain subsystem knows about its motors and its sensors and everything like that. But then what happens is the subsystem doesn't know how to drive itself. It just knows what its internal hardware is, its electronics, whatever. And then the idea is that you can create commands which use subsystems to do something, to actually do something. For example, subsystem here. A subsystem can be a drivetrain, a wrist, an elevator, an arm, a shooter, something like that, right?
Mhm.
So each of these things knows about the hardware. But then a command is something that you actually want the robot to do. For example, drive, right? So what the drive command does is it tells the drivetrain what to do. So the command will basically like take the joysticks and convert and get the value of the joystick and then send that to the drivetrain. So look at this. Okay. Over here, see this? This is a little bit confusing, not just because like of how they did it, but I'm not gonna really argue. So what this is doing is it's saying this drive, well, let's see here. See this apply request right here? The return value is a command. Remember how up here, I think I deleted it, but I created my own command.
Yep.
And that command just did a bunch of like print statements. But what that command can do is there was something called not the command scheduler, commands composition, I think. No, commands. Here. Okay, so the structure of a command. Okay, so there's a command class that's given to you by WPIlib, and it has a few different methods on it that if you want to override it, you can. The main methods are initialize, execute, and end. Initialize is called right when the command is initialized. So for example, if you want to start shooting and you press a button, it's gonna schedule the shoot ball command or whatever, or shoot note, or like launch note into a goal. Okay. That right when you press that button and you schedule that command, this initialize function is called. So if you have something like if you want to set some variables or something right when the command is scheduled, you put it in the initialize. What we were using so that it prints it loops every 20 milliseconds is there's an execute method. Inside of here, the code inside of here is run every 20 milliseconds. Okay, so if you need to like change something, if you need to act every loop cycle, then you put it in the execute, and then the end is called right at the end. Okay. So going back to here, what this is doing is this apply request is, I mean, it's kind of like a little abstract. I don't really, whatever. The apply request is taking in a supplier, whatever.
Mhm.
But what this is doing here is this drive dot with, I don't actually know, like, I mean, it just came with this code. But the idea is that whatever is in here, actually we can take a look. See this request supplier? So this run is kind of like a shorthand for whatever's in here, run it every 20 milliseconds in the execute. Look, construct a command that runs an action every iteration until interrupted. So this right in here is run every 20 milliseconds. See this request supplier .get? When that .get is called, this is computed, is run.
Right. Okay.
So that's what it's doing. Right? It's not magic. So this is run because in the apply request, this .get is called, which requests that thing that's passed in to give you a value.
Okay.
Yeah. And then this drive dot with velocity, the reason why this is field centric, I guess this is a field centric thing. What's the
Right.
value? Square request. The reason is because what you do is this is defined up here, and you can actually have swerve in one of two modes. You can have it field centric and then robot centric, because our drivetrains in the past, which have not been swerve, it always has to be robot centric, because the translation on the field is like locked, is like tied to the rotation. So you can't really do much. You kind of have to drive it like a car. But because swerve, the translation is independent of your orientation, field centric means like if you press up on the joystick to go forward, it'll actually go forward with respect to not the robot but the field. So the robot can be like this, but if you press forward, it'll go like this.
Right.
It's like relative to the field.
We had some issues with that today. I don't know so it seemed to be going robot centric, but we didn't think that was possible with the code. And we recalibrated the pigeon and everything was fixed. I thought you should just kind of know that.
Oh yeah.
The yaw was giving us all sorts of random reads on the pigeon. So we recalibrated and it worked.
Okay. Because
is there a switcher to robot centric?
we don't have it. I mean, you're probably not going to want robot centric at all.
No, we don't want it ever. So
yeah. So right now there's no robot centric.
cool.
This is basically the code that's being run. There's yeah. So, and then there's, so you see this apply request. That's just like creating a new command. So basically on the robot, if you hold the A button, it'll like break. I don't know if you saw that today.
That's break mode?
Yeah.
Or that's just cuts power. Or like.
So break is actually really cool. Because look, it sets a swerve drive module's states to point inward on the robot in an X fashion.
Oh, shit.
Basically what
It's like
happens,
a hockey stock.
Yeah, exactly.
That's
That's
sick.
how
I didn't know that.
because if
Because
it's
it's
all
always on break mode, isn't it?
what?
Like the Falcons are always like on break mode. So when you're off throttle, it comes to a stop.
No, so this break right here is nothing to do with
No, I know it's different. I
break
know
mode. So do you know what break mode is?
it's not reverse current, but it tries to stop all movement.
Yeah. Basically, it shorts the two terminals. So there's
Oh,
a
right.
plus and a minus. And I mean, it doesn't short it because then
It would kill your battery.
back in my day, when there was a guy on the team, and he was like he was head of electronics, and once he took the two leads of the battery as he was like wiring up the battery, put it together, and let's just say there were fireworks.
Yeah.
But it basically kind of does the same thing. So it prevents movement. So
Right. 'Cause
there's
when you put two ends of a motor together, it'll like lock up, right?
kind of, I think it was like Howland brake mode. You know what it actually is doing. I mean, I kind of have an idea, but I mean that's the basic idea. So there's brake and coast mode.
Right.
So yeah.
So I joined this. I didn't know how in depth you guys were with the coding. It's kind of cool, but I joined to obviously learn a bit, but also like to update you on what we're probably gonna need, if that
Yeah.
makes sense.
Totally.
So we're probably gonna need, and this is far down the line. If we're gonna use one April tag, it will be by the chute where we
Give
or
me just
the intake.
yeah,
where
let
you
me just commit all this code.
say that
So
again.
I'm gonna commit this and push it to GitHub. Just give me a second.
Yeah.
Are you going tomorrow?
No, tomorrow's Sunday. We got football.
Oh, I think they have robotics tomorrow.
I know, but it was kind of I had already scheduled something with my grandpa, so
Okay, that's
I'm
fine.
not canceling.
Okay, so I push that. Okay, so what were you saying? What were the requests?
So if we get to this point, we would like to do like tracking or something with an April tag by the source. So when we can line up in the same spot every day, every time.
Hold on.
We're not entirely sure what that looks like just yet, but that's a hope. And then I think that we're gonna want something that like snaps to, I guess, between 180 degrees. Like let's say we set the field centric thing to, and we want to be able to align with either like facing towards the driver's station area or the opposite, just based on a button, just so like we can reset if we need to, not have to steer it.
Hold on. Over here.
Yeah.
Say that again. What about the April tag right here?
No. Well, maybe that one, but you see the source? There are
Where's the
April tags on that source.
Right here.
Yeah. Where we'll be able to, if we could, you get to that source and you align yourself, and then we could just, with the human player, slide the thing in.
Oh, yeah. I mean,
That's down the line, but I thought I'd let you know.
the thing is that I really wish I'm in Atlanta, in Georgia.
Right.
I see it right here. And then where do you go? Sorry, where is the human player putting it in?
If you go to, we're gonna have like a ramp for it, or we could go straight into the thing. But
What thing? I just don't know.
the shooter. Oh, you mean where does the piece come out?
Yeah.
I'm not actually sure. I think that opens up like where that metal is. There's a slot
Yeah.
essentially. The gray.
Hold on. Yeah. I mean, yeah, this is very, I mean, it's relatively easy. Yeah. I mean, right, because like what we could do is like the robot is like facing this way. You can like have a button where if you press it and the robot knows it's like facing in this general direction, so it knows to like to snap to exactly this way.
Yeah.
See what I'm saying?
You mean snap to a path or?
Oh no, sorry. So let's say the robot is like at a 45-degree angle this way.
Okay.
Right, like up and to the right.
So it's facing the first in show presented by Qualcomm. Up at your top right.
Up at the
Yeah,
top right of this
so, like,
document.
Let's say the robot is here,
Yeah.
but it's facing like, yeah, first in show. What we could do is like, I mean, it depends on how we want to do it. If it's a button press that you do, right? How do you know like what the target is? Like
Right.
what angle is the target? So what we could do is like try to be smart about it. And like if we're like facing this way anyway, to the right anyway, then we say, oh, okay, we want to face directly to the right. You know?
Right.
And if we're facing to the left, that same button will know, oh, I'm facing generally to the left. So I'm going to make it go exactly to the left.
Right. So the Hawaiian, you remember the Hawaiian kids, right?
359?
359.
Yeah.
So I talked to the driver. I know that on their driver controller, I'm pretty sure their ABXY is like each cardinal direction.
Oh,
So
yeah.
it's to like every 90 degrees. So, I mean, maybe that's something we'd hope we'd implement one day because or just two of the directions, because you could get the shooter or the speaker or whatever, and the speaker is 90 degrees from the amp. So you wouldn't really use a lot of time lining up like that.
Hold on. Say that again.
So the speaker is 90 degrees to the right of, or to the left of the amp,
Yeah.
right? So if you had both of those cardinal directions on a button, it would make it really easy on the driver to line up because you wouldn't have to spend your time finicking with the turning.
Yeah.
I think that's something we will probably need at that point because like just watching Diego now, obviously he'll get better, but
Yeah, maybe you should have that.
he over rotates a lot.
I have an idea. Because this source here is not at a 90 degree. It's not on a cardinal.
That's why I said able tag.
You could do able tag, or what you can do, going along the same lines, is instead of using ABXY, you can use this over here.
The D-pad?
The D-pad. Oh, I think I have to get going.
Okay, sorry.
And somebody's up. I don't want them to know I'm up. Can you type this all to me in robot programming?
Yeah.
Okay. Take care.
See ya.
All right. Appreciate you. All right, dude.
Yeah. See you one day. Hopefully.
I will be there on Wednesday.
All right. See you Wednesday then. Enjoy Alaska.
Thank you.
How cold
Thank
is it?
Right now it's pretty warm comparatively. It's like 5 degrees maybe.
Oh, yeah. Or bathing suit weather.
I'll just say I feel like it's usually colder up here, so it's pretty shocking that it's warm. But
all right. See ya.
All right. See you, dude.